if you've been playing around in n8n and like you've been just trying to figure out data types, like why the hell am I getting a type error here? Like what the hell is even a type error? Well, you're in the right place because today we're dealing with data types in n8n. Basically, if you know your elements and you master their transformations, then you will be able to do a lot of things in n8n. By the way, for context, the name's Muzi. I am the Grand Alchemist of the Guild, and that was a car passing by, if you heard that. Basically, my mission is to help 1,000 people make $1,000 online using AI and automation. I just want to help people, and I want to make content while doing that. So, yeah, content, AI, automation, and AI automated systems are what I love. Okay, let me stop yapping. Let me just start. Let me get into this. So, data types are the building blocks of workflow magic, and I mean that for certain because what you need to understand is the fact that on the base level, when it comes to JavaScript, JavaScript runs on data types, right? So there's multiple data types, and everything like data is represented in terms of types. Um, this is very simple. So now on the top level where you have n8n running, any piece of data that's flowing through is obviously going to have a type assigned to it, either by you or by the system itself. So data types matter because understanding data types is just crucial beyond n8n, right? Because like it might be a low code tool, but you're still coding in some aspects, right? You still have to understand code when you're dealing with expressions with data mapping. By the way, we just did data mapping in the previous video. If you want to go check that out, it's totally my channel. But yeah, never you don't want to ever treat one data type as another one because that's when you get type errors, right? Because the type of data that you're dealing with also has operations that you can do on it. So what that means is if you are dealing with a number, then you can add it up, you can multiply numbers, you can subtract numbers, and so on and so forth. But if it's a string, you can't subtract a string, right? By string, I mean like an array of characters, a list of characters. Like my name is a string, like Muzi is a string, Muzi. So the M would be a character, and so on and so forth. Okay, we're going to deal with that later on, but yeah, you don't want to treat one data type as another one because then when you're running operations on them, you are going to start crying when you start seeing the errors that pop up. So yeah, you also don't want to send improperly formatted data forward either to other sort of like integrations, or just to like APIs and services. You don't want to do that. You want to save yourself as much hassle as you possibly can, and that's why understanding data types is incredibly important. So let's move on. Strings. Now, strings are text values, right? So, hello 23. Insert a really good example here. These are all examples. That was a really good example, by the way. Just to make sure that you understand anything in closing quotes. So, hello, or just a single quote. Even a slanted quote works. That is for templated strings, by the way. Templated strings are strings that allow you to dynamically assign certain sections of it, um, sort of like through code, through variables, I guess you could say. Very useful for if like when you're trying to create payloads on the on the like quickly and easily. Um, it's very useful. So yeah, we might run through something like that later on. You might see a lot of that going forward. But yeah, strings are perfect for names, messages, tags, and so on and so forth. And you'll see strings very often because most of the internet is made of strings, right? When you are sending maybe a request to your, like when you're sending an email to someone, you're probably going to format that in terms of HTML or text, right? That text is a string. If you're sending it and formatted in HTML, those HTML characters are also kind of strings. So you can format those as strings and pass them through there, which is like really interesting. Everything can be formatted as strings, and that is just the part. Like strings are everywhere. Like this page is literally just made up of strings. Let's move on. So numbers are numerical values, right? As you might expect, like 23 or 3.14, or the answer to every problem in the universe, 42. And you use them for pricing, for scores, for totals, and numbers are very useful just because of how like they are representative of data itself. So calculations basically, when you're adding things up, right? What that means when you're summing up values. Yeah, basically that's I just said the same thing twice. That's so funny. Um, Adding things up when you're finding averages. When like numbers are very useful, especially in relation to data. So yeah, you're going to be using numbers a lot. You're going to be seeing numbers a lot as well. So dates have their own formatting, and again, this is their formatting. So understand this is the year, the month, and the day, and then there's a capital T, and then it's the hour, the minutes, and the seconds, and then there's Z here, but it could also be other sort of like an even smaller time format where it's like milliseconds and microseconds and so on and so forth. But yeah, if you like once you have this time format down, you can do some really cool stuff with it. Like you can schedule things, you can delay things, you can filter things. Like think about sending something to a like a like updating your calendar. You want to update it at a certain date. You need properly formatted dates for that, um, which is very like it's something you can do very easily in n8n. So arrays. Now, if you remember properly from 2.1, this is something we dealt with before. We call them lists. And this is just the way that n8n understands things. So everything is represented in terms of lists of items. That list thing, that square brackets, is an array. So arrays can hold anything inside them. Um, you can have arrays of strings like apple and banana. You can have arrays of numbers like 2 and 3. You could have arrays of like mixed elements like 3, banana, and then this you might recognize as an object with a key value pair. Again, we're going to run through that very soon. But yeah, arrays are perfect for batching and ordering, and it's because they're indexed. So every item has an index. Arrays start counting from 0. So the first item is item 0. The second item is item 1. And you can index these items like programmatically in your code, which is very useful in your expressions if you want to index a certain item. So say hypothetically you sorted them before, now you want to item, the top one, which is like very useful if you're doing it through an expression. So yeah, they're perfect for loops as well, since loops understand arrays best. They want multiple items coming in, and that's just the perfect way that they will understand this. So objects again, you might recognize this because, as I said, the way people call objects in the internet is an item. Objects are items, and items or slash objects have key value pairs. So like me, if I was a person object, I may or may not be objectifying myself right now. Okay, so the name key would be Muzi. And again, keys are also known by a different name. They could be called fields, right? Something to remember. So the field or the name, or the field or the key is Muzi, and the field for role is Grand Alchemist. So they are the core format in n8n because everything runs in terms of array, like lists of objects or arrays of objects or lists of items or arrays of items, right? That the next data item that the next data type that you need to understand is the Boolean type. So these are just simple true or false values, but it's very interesting because they could be represented in all these different ways. Let me explain to you. So there's something called type conversion, where you take a type and then you convert it to another type. So what that means is you can take a number and then convert it into a string. You could take a string and then convert it into a bunch of numbers. And this is all just because at the base level, everything is represented in terms of numbers, right? Every character is a type of number value. And then when you sort of put them together in a string, that's also can be represented as a type of number. Um, so there's some, yeah, basically just understand that everything can be converted by types, meaning that if you had some way to represent a true value and a false value, those could also be represented in terms of numbers. Realistically speaking, the true value is always 1 for anything but 0, and the false value is always 0. Now let's think about what this means in terms of types. Let's look back at the string type. So the string type is made up of an array of characters. Again, you don't have to go too deep into strings. Just understand that they are arrays of characters. Okay, this character is in position 0. This character is in position 1. Like, we're not going to go too deep, but just understand that. Now, if it's an empty string, then that means that there's no characters inside it, which means it could be represented as a 0 for value, as a false value, right? But anything with characters inside it, any string with characters, is a true value. That is the type conversion for Boolean for strings. For numbers, as I said, any value that is 0 is false, any value that is 1 is true. Or like any other value for a number. So it could be 2, it could be 5 million, it could be 780,000, it could be even the answer to every problem in the universe, 42. Dates, again, they could be type converted into values. Dates are a bit more interesting, right? Because of the fact that you can't really have a date of 0. What that means is there is a base number for, like, there is a sort of operator for dates where it's like, it's called the value of operator, and it gives you like a value for any type of date. It's very interesting when you use it. You start seeing these numbers. It seems random, but everything actually makes sense when you look at the sort of the back end of the code. It's just a number representation for a date, and every system can understand this number representation because it has information on not only sort of like like it has information for just the date basically. So yeah, even this could be even this can be type converted into a um, boolean, which is very, very interesting. So arrays, as I said before, um, an empty array would be a false value in terms of boolean, but a non-empty array would be a true value for boolean. And objects, again, uh, an empty object, or I guess a non-existent object, would be a null object, and it would be the false value for boolean. And then an object that actually has key value pairs inside it would be a true object. So yeah, booleans are very powerful, and they're perfect for filters and logic operations. Like, if you remember, you have to sort of specify type conversion, but yeah, you can, like, use these for like really good logical operations, and logic is always really good for like making smarter workflows, and we'll go through this in the future, just so you know. So there's also another type, which is HTML, XML, you know markup language that is understandable by frameworks. So let's actually just go through and just look at these. um, what we want to do here is we want to come in here and we want to see how this edit fields node is actually like kind of thinking about data types here. So we're defining this data. We're defining a string key, and the string is of type string, and whatever is stored in here is string. We're defining a number, and this number is a number type, and this type is defined as 23. We're defining a boolean, and this is a boolean type, and the type and the value is false. We're defining an array. It's obviously a mixed array here. We are defining an object, and we're defining everything that, so it's like the key value pairs inside the object. And again, it could define all these different types here. We're defining a date here, and the date we're defining it as now, and then we're defining some HTML as a string, remember. So when we run this, you might see something interesting happen here specifically, and I want to show you what's going on. So look at the output. It has double um, it has double quotations, so it's two double quotation, which is very interesting, but that's just what happens. So because this is a character that can be represented, um, that's why when it's doing type conversions, it just converts the character itself anyway. So if you want to define strings without those, double quotations, then you you can just like name it like this. You might be wondering why I didn't do that here. It's because we defined it as an array. And again, here we didn't do anything funny, and here we didn't do anything funny either. So that is basically how it happened. It has all our keys that we defined, and it's even storing them in a way that looks really good. Like I feel like it looks great. So now you might be wondering what's going on in the next step. Well, the next step is markdown. So I'll just run that first, and then we'll come in here and see what's actually going on, sort of like in a deeper version. What this is doing is this is turning HTML to markdown. So what that's doing is it's looking at this HTML. So if you understand HTML, you understand that it works with opening and closing tags. So this HTML tag is an opening tag, and then everything that is a backslash whatever is a closing tag. So that's backslash HTML. So that's body backslash body. So like heading one and then backslash heading one. Whatever's inside there is defined as heading one type, and then paragraph backslash paragraph again paragraph type, and so on and so forth. So this is just a standard framework that websites understand and use to display information to people like us, like you and me. Here what it's doing is it's getting this HTML, right, that we stored in the HTML variable, and it's mapping the key. So it's creating a new variable in the output item. And what we want to do is we want to set it as like what we could type in whatever name we want here, but we typed markup and it created a new markup. Uh, we created a new markup key, and here it's delineating it as markup. So you might recognize this hashtag. That is just the way markup understands headings. So for the heading one type that you'd normally see in HTML, it has just the hashtag, one hashtag, which is very interesting. If it was heading two, then it would be two hashtags. If it was heading three, it would be three hashtags, and so on and so forth. And for every paragraph, it just gives you new lines, which is very interesting. So you could think about how you could like use this very easily. So like understanding, maybe you just scraped a web page, you have a bunch of HTML data, right? You could just convert it to markdown and then get rid of all these heading and other sort of like things, maybe using a model. Just use like get rid of the hashtags, and now you have like a really good solid piece of text that you could actually work with. Okay, let's keep going. So that was basically markdown. So HTML and markdown, um, they are markup languages that are understandable by frameworks. So this is a type for XML that I didn't show. XML just has more content. I mean, more context. Um, there's the content sort of tag. There's all other types of tags like title and so on and so forth. You could learn the XML. It's a ton of documentation out there. I personally did not learn it. I've only learned HTML, but that's just because I find it more useful. And to an extent, it is because XML, you you do see it often, but you're always only seeing it getting converted to and from HTML or to and from any other type. Um, but yeah, I mean, I guess it's worth learning just for like the amount of context that it's able to bring to your creations. So yeah, these are perfect for email formatting, web scraping feeds, and so on and so forth. Think about maybe sort of if you have some output from a model and then you want to format it in terms of HTML so that someone could so that you could send it as an email to them, that an email that actually looks good with some styling elements and everything. You could have a markdown. You could have that same node that we just used, a markdown node, but you could have it turn markdown to HTML, and then you could like drag in your markdown that you're actually using. Really powerful, like no matter how I think about it. But yeah, let's come back. So next, there's binary data. Now this is the most useful data, but it's also most complex as well. Binary data is basically just files. So think PDFs, think images, think MP3s, think videos. Um, what you want to do, I've seen this happen a lot. What you want to do is you want to store it on your file system if it's too big, or like if you're not using it sort of like immediately. The most useful thing for you to do is to just store it on the file system and then delete it from the file system later on if you have to. Um, or just pass it to some cloud storage so that you can call it by URL or something. Um, yeah, but like yeah, the binary data is it's great. Like you can upload it, you can download it, and just you have to pay attention to data complications because if you download too much data, your workflows will tend to break more often than not. Um, we might do some stuff with date binary data just so that you see, but like it's very it's very important for you to understand this simple thing. So let me show you. So here we have a simple workflow where we're getting a bunch of MP3 elements from that was stored on Airtable, right? And mind you, these are not items; these are URLs. And this limit node is going to limit them to only one item, so that we only just get one item. And then here, what we want to do is we're sending an HTTP request to this URL. Since it's a publicly accessible URL, what it's going to do is it's going to let us download it. We don't even need any authentication for this. Let me test this step just to show you. So it's gonna take a while to do this, which is like the annoying thing about this. It's like you don't want to be playing around with data that's too big, but once you sort of manage it, then this was a file size of like 7.4 megabytes. Once you sort of manage it, what you could do is you could just save this in your file system. So you could rewrite files from this. You could write the file to the disk, basically. The input would be this binary field, and you want to, you could like set up a file path or name. Um, yeah, just set it as the same name from here, I guess. But you probably want to um, do this programmatically. We'll just do it like this right now, just to sort of show you how it works. Okay, so it's telling you to not just execute this, so it needs you to run it sort of through proper testing, so like testing every single node at the same time. Um, let's just see how it goes. Okay, perfect. So that was how you do it. Now we have a file stored in our file system. And the funny thing is that we can actually just call it from anywhere. We don't even need to connect to that. Why am I adding a sticky note? I guess I love them that much. Let me add a note here. It's going to read file from file system. We want to read the file from the disk. And remember the file name. It's going to be this one. Now, when we test this step, like we don't have any real connections to that, but it's going to be able to read it and then um, upload it so that like we can actually use it in the workflow, which is really powerful no matter how I think about it. So yeah, binary data is very useful, um, you know, and you might find use for it in your workflows, which is really impressive. That was my alarm. Okay, let's keep this going. I'm human, so let's keep this going. Now, there is a really interesting sort of way to think about this because once you start understanding data types and data structures, you start coming up with different ways to sort of format these things into custom data structures that your system could understand so that whatever system you're trying to build, or maybe custom data structures that other systems are using to understand any data that's coming through and interacting with whatever they've built. Um, to interact with these, what I've found useful is using the code node to set up payloads. I'll just run you through it very soon, but yeah, you use the code node to set up the payload, and in that payload you define the object that's being sent through, um, and then you want to do something like a nest. You could have nested arrays or any other sort of like data set, depending on whatever service you're trying to communicate with. But yeah, basically what you normally find is that you have all these API specific payloads that you need to like sort of set up for um, to account for. And custom data structures actually help you deal with this really effectively. Like I know I was recently researching how to um, create documents that actually look good, that aren't just text, that actually have like titles and proper formatting, like that look like they've been edited by a human being. And I had to look through the API, and I realized that documents are actually sectioned, like they are sectioned um, between the body, and the body has its own sort of like text sections, and every text section has like elements inside it, and so on and so forth. All of that like can be accounted for. Okay, this example I'm about to show you is not really the same. Just a simple code node. Um, what I'm going to show you though is like an interesting payload that I could be sending. So here, this is the JSON, it's the data, right? Custom data, whatever. You could have this name as anything you want. That's a nice thing. I like to look at this in the schema view, just to show you. So, like, imagine you're sending some kind of user ID, some session duration that they spent on your site, any types of like sequence of actions that they took on the site as well, their location data, their preferences, and then the engagement score that you calculated or something. Um, and now you're sending it to get sort of analyzed even further, maybe. You could do that through an HTTP request, right? This is something I do often. So I have all this data and I want to use it really well. I will send the data in the body. What I want to do is I want to format this as raw, and I want to say that the content type is application JSON, and I want to say that the body of content that I'm sending is this data. So right now we just map that data in there, and you could have this URL as any kind of like URL that you want to send information to. But yeah, this is how you would do it. Like, like what I do, something that helps me out really well, is it like I format my data in a code node, in a God node, and then I just send it as a raw sort of like piece of as a raw object in the body content of the HTTP request. So yeah. And of course, there's like tons of real world use cases. So for data type specifically, you want to use strings for names, you want to use numbers for budgets, you want to use dates for submission tracking, you want to use booleans for callbacks and tracking. Like imagine if you contacted someone but they didn't contact you back, right? You could have a boolean that checks that. If they did contact you back and then you followed up on them, you could check that, and so on and so forth. So there's like levels of complexity, and all these data types actually help you um, sort of account for each and every one. And if you actually apply the right data type in the right places, then you will win. So let's just wrap up. So you have to master the types to master their representation. Remember, there are strings, numbers, dates, arrays, objects, booleans, HTML and XML, binary data, custom data structures, and yeah, if you use them wisely, then you'll get a ton of traction. So I'm sure you're ready to dive deeper. I know I am. So next time we're going to be looking at data flow, controlling it, stopping it at will. What does that mean, and how do you get involved? I'll see you there, fellow alchemist.